Hello everyone, this is mathematics lesson for grade 8. This program is organized by Addis Ababa City Administration Education Bureau in collaboration with Addis Media Network. I'm teacher Mamu. Today I will teach you the 5th unit of grade 8 mathematics. Okay, so as you all remember, in our previous lesson we have started the 5th unit, which is about theorems on triangle. And we have seen the first theorem on the 5th unit, which is about the sum of the interior angle of a triangle is 180 degrees, right? So that is the first theorem that we have seen in our previous lesson. Do you remember how we proved this fact? Suppose we have a certain triangle ABC. The triangle is a triangle with vertices ABC. Say the interior angles are alpha, beta, and theta, okay? Say these are the interior angles of this triangle, and we have proved that alpha plus beta plus theta is 180 degrees. You all know that the sum of the interior angles of a triangle is 180 degrees, but in our previous lesson, we have seen how this fact can be proved, right? Just to prove this thing, the first thing that we did is we constructed a line passing through one of the vertex. Say, take the vertex C. If you construct a line passing through this vertex, say that line is L, this line is constructed in such a way that it's parallel to the other side, that is AB, right? As you all know, if you have parallel lines and a transversal line here, AC can be considered as a transversal line, okay? You all know that for a parallel line and transversal line, the alternate interior angles are congruent. That means if this is alpha, this should be alpha, right? Again, by considering BC as a transversal, you can take this angle and this angle, okay? By alternate interior angles, these two are congruent. Therefore, you can say this is also beta, right? Now you can observe that the sum of all these three angles forms 180 degrees, right? If they form 180 degrees, clearly the sum of these three, alpha plus beta plus theta, will give us 180 degrees. So this concludes the sum of the interior angles of a triangle is 180 degrees, right? All right. So based on this proof, we have seen different examples. I will give you one example just to brainstorm what we have seen in our previous lesson. For example, if you are asked to find the unknown variable x, where one of the angle is 4x, the other one is 6x, say the third one is 80, okay? In this triangle, if you are asked to find the value of x, okay? If you are asked to find the value of x, you need to add all these three and sum it up, and the result is 180 degrees. So you can calculate the unknown variable in this way: 4x plus 6x plus 80 degrees must give us 180 degrees based on the theorem that we have already proved, right? So here you may forget the proof, that's okay, but you should remember the result on theorem 5.1. You have to know the sum of the interior angles of a triangle is 180 degrees. This fact should be known so that you can calculate the unknown variable that is given here in this triangle. So can you guess what the value of x should be here in this example? Just take 20 seconds and try to find the value of x in this case. Well, to find the value of x, I hope you did this procedure. You collect like terms here. 4x plus 6x is clearly 10x, plus 80 degree is 180 degree. Then you shift this thing to the right, or you can subtract the same quantity from both sides. So this gives us 10x plus 80 degree minus 80 degree is equal to 180 degree minus 80 degree, right? Now, on the left side, it remains 10x because this term is 10x plus 0 is equal to 100 degree, right? Or you can simply transform this thing to the right side, then 10x becomes 100 degree, right? So the last step will be dividing both side by 10. Okay, whenever you divide both side by 10, the value of x becomes 10 degree. 100 by 10 is 10 degree. Look, you can check whether your answer is correct or not by substituting the x value here, right? Come on, let's substitute x in each of the angles. For example, here 4 times x, okay, 4 times 10 is 40 degree. Okay, one of the interior angle in this case is 40 degree. And whenever you substitute x in the second case, 6 times x, that means 6 times 10, the result is 60 degree, right? So the second angle is 60, the third is already known, which is 80 degree, right? This answer is correct if and only if the sum of all these three angles is 180 degree. Otherwise, your answer is not correct, right? Because by theorem 5.1, the sum of the interior angles of a triangle must give 180 degree. As you can check, the sum of all these three is 180 degree. Because 40 plus 60 is 100. 100 plus 80 degree is 180 degree. So in this way, you can calculate the unknown variables, right? Good. So these are the things which was discussed in the previous lesson. Today, we will have a discussion on theorems on exterior angles, okay? Theorem 5.2, which is the second theorem in this unit. This theorem is about exterior angle theorem. Exterior angle theorem. Okay, what does this exterior angle theorem says? The exterior angle theorem says that the sum of two remote interior angles is equal to the exterior angle, right? The sum of two remote interior angles equals the exterior angle. The exterior angle. Okay, so we can paraphrase this statement geometrically. Okay, geometrically, this theorem can be expressed in this way. Okay, for example, if we have a triangle with an extension on one of the vertex, okay, you need to have a certain extension so that you will have an exterior angle. So say this is x and this is y, okay? These two are called remote interior angles, and the angle which is found somewhere outside, say z, okay? This z is the exterior angle, right? So whenever we say exterior angle, you need to have an extension on one of the vertex and construct an angle outside the triangle. So Z is the exterior angle, X and Y are remote interior angles to Z, right? So this theorem tells us the sum of these two remote interior angles is equal to the exterior angle Z. That means X plus Y is Z, right? This is the geometric interpretation of theorem 5.2. To prove this theorem, we need to apply the concept that we have seen in the first lesson, okay, in the previous lesson. In our previous lesson, we have seen that the sum of the interior angles of a triangle is 180 degrees. That means X plus Y plus W is 180 degrees, okay? So you can take X plus Y plus W is 180 degrees. Okay, this is based on the theorem that we have seen in 5.1. Okay, the other thing that we need to know is W and Z together forms a straight angle, right? So W plus Z should be 180 degrees, right? W plus Z should be 180 degrees. So we know these two things. Now, if these two are the same, which is 180 degrees, by transitivity, we can take these two expressions are the same, okay? So X plus Y plus W is equal to W plus Z, okay? These two are equal because both of them are 180 degrees. So now subtract the same quantity from both sides. Okay, you can subtract W from both sides. So this equation becomes X plus Y plus W minus W is equal to W plus Z minus W. Okay, so now on the left side, this will be 0. And the only thing that left here is X plus Y. X plus Y is equal to, this can also be cancelled each other, then it remains Z, okay? So this tells us the sum of these two remote interior angles is equal to the exterior angle Z, right? So this is how we can prove the exterior angle theorem. Now, based on this theorem, we will see different examples that requires the concept of exterior angles. Okay, now let's see examples. The first example, in the first example, say example 1, if 48 degree and 52 degree are the two remote interior angles, the two remote interior angles, then find the exterior angle. Okay, look here, what's given? The two remote interior angles are given, and based on this, you are asked to find the exterior angle. Okay, so the first thing you need to put this this thing geometrically. It's not necessary, but you can represent this thing geometrically. Okay, so whenever you write this thing, you can write like this one is 48 and this is 52, because these are the two remote interior angles, and this angle is X here, right? So based on the theorem that we have seen before, you can easily calculate the exterior angles. So simply the exterior angle X is the sum of the two remote interior angles as we have proved. So X should be 48 degree plus 52 degree. Okay, so you can add these two numbers. I think the sum of these two numbers is 100. So x is 100 degree. Okay, you can also answer this question in a different way. Okay, this is based on the theorem 5.2, but you can also calculate this x value based on the first theorem that we have seen. If you remember, in the first theorem, we said that the sum of the interior angles of a triangle is 180 degree. Say this is angle K. If you say this is angle K, these three should be 180 degree. That means 48 degree plus 52 degree plus K is 180 degree, right? So the sum of these two is 100 degree plus K is equals to 180 degree. So K can be 180 degree minus 100 degree. That means K is 80 degree. Look, if this angle is 80 degree, since K and X together forms a straight angle, K plus X is 180 degree. Okay, since K is known, K is 80, so 80 degree plus X is equal to 180 degree. So now you can transform this number, then X becomes 180 degree minus 80 degree, which is X is equals to 100 degree, which is the same as what we have this one. I'm sure you don't prefer this way of finding the exterior angle, but there are different ways to find the unknown variables that you have here. Okay, so this is the first example. Now let's see the second example regarding exterior angles. In example 2, find the value of x and y in the figure shown below. In the figure shown below. Okay, the figure looks like there is a triangle. There is a triangle with degree here 65. This is x. This is y, and this one is 135. Okay, so from this figure, you are asked to find the value of x and y. Okay, so I hope you will apply the concept of exterior angle theorem. I want to give you 1 minute to practice this thing, then we will see our answer. Just take 1 minute to find the unknown variables x and y. Good. I hope you tried the solution. So to find the value of x and y here, we need to apply the theorem 5.2, which is the concept of exterior angles. So based on the concept of exterior angles, the sum of these 65 and x must be 135 degree. 135 degree is exterior angle, and these two 65 and x are remote interior angles. So this gives us, okay, this gives us x plus 65 degree is 135 degree. So now we can get the value of x from this equation. Okay, you can shift this 65 or subtract both sides by, subtract 65 from both sides. Then x becomes 135 degree minus 65 degree. Okay, the difference of these two numbers is 70. Okay, so from this figure, we get that x is 70, right? This is the value of x. Well, to find the value of y, you have two different options, but I prefer to use the concept of a straight angle. Okay, y and 135 together forms a straight angle. So you can easily say y plus 135 degree is 180 degree, right? So take this number to the right, then y becomes 180 degree minus 135 degree. And this difference is 45. Okay, so this way we can calculate the unknown variables x and y, right? Now let's see another example related to the exterior angle theorem. Okay, in the figure shown below, in the figure shown below, find the unknown variables. The unknown variables. Okay, our figure in the third example is like, suppose we have a combination of triangles having this form. Okay, somewhere here there is an exterior angle. Okay, say this angle is 40 degree and this is 30 degree, and this angle is A, this is B. Say this is 50 degree, this is C, D, E, F, and 100 here. Good. Here in this figure, we have different combination of triangles connected in this manner. So in this example, you are asked to find the unknown variables A, B, C, D, E, F. There are around 6 unknown variables in this figure, and you are asked to calculate these unknown variables, right? So take 1.5 minutes to calculate the unknown variables, then we will see it together. Well, I hope you tried your own answer. Let's see how we can calculate these unknown variables, right? So it's good to start from this part of the figure, because on the left side we have two known angles and one unknown angle. Okay, to calculate the value of A, we need to apply the first theorem, or the theorem which deals about the sum of the interior angles of a triangle. Okay, you need to keep in your mind that the sum of the interior angle of a triangle is 180 degrees, so that we can calculate the value of A. Okay, so these three angles, 30 degree plus 40 degree plus A is 180 degree. Okay, from this we can calculate, or we can obtain the unknown variable A. So the sum of these two numbers is 70. 70 degree plus A is 180 degree, right? So the value of A becomes 180 degree minus 70 degree. Okay, this implies A is 110 degree. Okay, we have the value of A from this, right? To obtain this angle, you need to apply the concept of vertically opposite angles, right? Do you remember what this vertically opposite angles looks like? Always, if you have two intersecting lines, you can get vertically opposite angles. Okay, this and this are called vertically opposite angles, and they are congruent. And you can also consider this and this. Okay, these two pairs of angles are also vertically opposite angles, and they are congruent, right? So A and B are vertically opposite angles. So immediately you can get the value of B from A. So A and B are the same, which is 110 degree by vertically opposite angles. That is the reasoning that you need to state, right? So we have B value here. B is 110 degree. Now let's proceed to the third unknowns. Okay, here the third unknown is C. In this case, we have angle B, which is 110, and another angle which is 50 degree. So the sum of this B, C, and 50 is 180 degree, right? So B plus C plus 50 degree is 180 degree, right? Because it's one triangle. Now, we have already obtained the value of B, which is 110. So you can substitute in place of B 110. This gives us 110 degree plus C plus 50 degree is equal to 180 degree, right? So now you can add these two. 110 and 50 degree is 160 degree. Okay, so C plus 160 degree is 180 degree. Now you can get the C value. Okay, subtract this thing from 180 degree, and C value becomes 20. Okay, in this picture, C may not seem like a 20 degree angle, but I'm just telling you the procedure on how you can calculate the unknown variables, right? So now we have obtained A value, B value, C value. The value of D can be obtained automatically, right? These two are congruent. C and D are congruent by vertically opposite angles. So if C is known, D is also known. Okay, so D and C are the same, which is 20 degree, right? Now we are left with two more unknown variables, okay, E and F. Here, you can easily obtain the value of F, because F and 100 forms a straight angle, okay? F and 100 forms a straight angle, so that you can say that F plus 100 degree is 180 degree. So from this, you can get the F value. So F is 180 degree minus 100 degree. This gives us F is equals to 80 degree, okay? Now, we are left with only one unknown variable, which is E, okay? This can be obtained because D is already 20. We have D here 20, F is, this is 80 degree, right? So D, F, and E forms the sum of the interior angles of a triangle. To find the value of E, we already have the value of F, which is 80 degree, and the value of D, which is 20 degree. We are left with E, okay? So, since these three angles forms the interior angles of a triangle, you can say that D plus E plus F is 180 degree, right? So now we have already D value, which is 20 degree, plus E plus F is 80 degree. Okay, we have F is 80 degree. So this must be 180 degree, right? So the sum of these two is 100. So E plus 100 degree is 180 degree. So now you can easily obtain the E value, okay? You can shift this 100. So E becomes 180 degree minus 100 degree. So E value is 80 degree, okay? This way we can calculate the unknown variables A up to F, right? So if this is clear, I will give you one practice question for you to practice it. Hopefully you can try and calculate all the unknown variables, right? So this is your homework. Calculate the unknown variables, in the figure below. In the figure shown below. Okay, our figure looks like exactly what we have seen in our previous example. So I will change only the given thing here. Say this angle is 35 degree and this is 70 degree. Assume this angle is 25 degree and this is 95 degree. Okay, say this angle is A, B, C, D, E, F. So from this figure, you are asked to calculate the unknown variables A up to F. This is a practice question for you to practice it. Take this thing as a homework. So this is all for today. So in this lesson, we have seen the concept of exterior angles and how it can be proved. We have also seen some examples regarding exterior angle theorem. So these all are the things that we have seen for today. So based on the examples that we have seen so far, I need you to practice this thing. So thank you. This is all for today.